Hello, everyone.
Good afternoon, sir.
Yeah, good afternoon. Some audible, right?
Yes, sir, you are.
Yes.
All right. So you'll start in 1 or 2 minutes. So we'll start the class now. Last class we were just seeing how we did some practical sections on classification and regression programming. So in this class, so this is kind of like an extra class. So if you have any specific doubt, you can ask that. And what I intend to do is like I'm going to discuss some theory about classification, then regression classification and k-means. Right, so we'll start. What major problems does MLs or machine learning solve for decision making, right? So mainly we can classify the problems as classification problems. So in which we classify a set of data into two. So it can be a simple classification or it can be a complex classification problem. Or the next, so I think the last class we did an example of income wise classification. And The next one is function approximation or regression problems. So in this function approximation or regression, what we do is we will try to approximate a function or the values of a function from by giving the input. So it's like predicting the house price or predicting any value. All those comes under a function approximation or a regression problem. Right. So these are some of the major problems that we can do, or some of the examples of machine learning problems that we can do. So let's see how these can be classified. So fraud detection in a credit card transaction, that is a classification problem. Then distinguishing between a cat and a dog, like an image classification problem, or detecting any failures in a motor. So it's if the motor is working or is it failing, that's also a classification problem. And understanding churn based on email communications, that's another classification problem. And coming to the regression problems, we have the predicting, like the material property or predicting the scores in a cricket match, and all those reaction problems, and also value of a board position in a chess game. So all this comes as a regression problem. So first, what we'll see, what is a regression? So regression is nothing but it's a supervised learning that builds a functional relationship between dependent and independent variables. So what does that actually mean? So we will sometimes predict the house prices based on a lot of variables. So like the location or the number of bedrooms in a house, the facilities that colony or the facilities that the apartment provides, all those comes as the uh, variables. And another example is stock price. So stock price is also another yeah. Are you having some doubt?
I have a doubt, Azhar, on the previous
Is there
slide that
any
you
issue or am I audible?
you are audible.
Okay, fine. Just a minute. Right. So the regression type of problems can be classified into univariate and multivariate problem. That is, if the final prediction or the final dependent variable is dependent only on one independent variable, it is called univariate. Or if it is on multiple independent variable, then it is called the multivariate problem. So the dependent variable is nothing but our final target or final goal. So in both these cases, we have the house price as our final target. And here we are considering only the square footage to predict the house price. Whereas in here, in the multivariate case, we are predicting both the square footage as well as the number of bedrooms. Now coming to regression types. So we have linear regression and non-linear regression. So it's kind of like if the relationship between the dependent and independent variables are linear, then we can fit the regression curve using a straight line. So that kind of problems are called linear regression problems. And for non-linear regression, the relationship is non-linear. That is, we cannot fit a straight line or a more non-linear function will better predict the outcome. So we have different methods to do the regression problems. So in linear case, we have the most common ordinary least squares, then ridge regression, lasso regression, then we have the partial least squares and principal component analysis. Whereas in case of non-linear regression, we have the polynomial regression, then we use the neural networks as well as the spline regression problems. So let's try to understand the flow of how a regression problem or the regression works. So first we have to start and we have to formulate the problem. That is, we have to choose a set of variables. Then we have to form the model, then the method of fitting that we have to choose. And if you have any specific assumptions, we have to do all those that all constitute the formulation of the problem. Then we have seen that we fit the model. So in the last class during the in the notebook we have, or the Python program, we have seen that we'll fit the model, that the model will train. Then we can validate the model, like we can see the error, or if there is any outliers or sensitivity analysis, and we can see if our results are okay. We can move towards evaluating the model, like using the unseen data. And if it's still okay, then we can stop and we can use the model for model for predicting or classifying the for predicting the price or the whatever intended task. If there is any if the results is not satisfying, then we'll have to go back, then formulate the problem in a different way, or we'll have to change the independent variables and all those things. Or we have to change some we have to change the model itself. So we had seen, like in the last class we used different models and we got different results. So let's see the illustration for a regression.
So there is so much
So
of
we have the
background disturbance.
data set of car service center. So this is the cars, then we have the minutes on the y-axis. So it contains number of cars, which is the independent variable, and minute for service is the dependent variable. So yeah, Riaz, do you have any question?
Sir, there is a background noise.
Yeah, so there is so much of
Somebody is
noise
raising
from the
hand. So
background.
if you have any question, you can unmute and speak.
So can you please mute the person who is
Okay.
talking in the background?
All right. So what we want to do by this regression task is that we want to find the best functional relationship between both variables. So the first thing is we have to model. Now here we are using the ordinary least squares. So we'll find a linear model between y1 and x1. Here we have only one variable, so the xi will be x1. Then we have some error. So error is only dependent variable and no error in independent variable, because the number of cars is not a probabilistic distribution. We know how many cars are coming. So the error will be calculated only in the dependent variable. So here, if you see the error, so E1 or the epsilon 1, this is the error. So it is calculated only in the dependent variable, that is the minutes. So error is calculated by the defined line minus, sorry, this is y1 is the actual minutes. Then beta naught and beta 1 are the parameters of the line. So finally, what we want to do is we want to minimize the error So if you calculate the error from each point to, or the distance from each point to the line, and we sum it, then finally we are going to get the total error. So our aim is to minimize this error.
So for which problem statement are we using this?
So this is the total error, that is we are adding the distance from the line to each point parallel to y-axis. Then if you know the minimization, like if you take the derivative with respect to beta naught and beta 1 of this equation, then finally if you solve, you are going to end up with this formula.
So there is so much of background noise.
Sir, where we will use these all equations you are explaining?
Yeah, somebody's raising hand. So if you have any doubt, you can unmute and
Sir,
speak.
where we have to use these all equations?
Do you have any doubt?
Sir,
Sir,
doubt,
you are
sir.
Sir, you are explaining the equations where we have to use this all. Just
So
can you give
continue.
a overview?
Now, how to test the goodness? Manoranjan and Hema, do you have any doubt, or you have raised
Sir,
your hand?
your voice not clear.
1 minute. Yeah, speak. Hello?
Yes, sir. Sir, we have to use these equations where? Can you give just a overview?
Which equations?
This all, this so you were explaining that. Just can you give an overview where we have to use this, the basic concepts?
Yeah, we will see some examples. So in that it will be clear. All right.
Okay, sir.
Yeah. So this is R square metric that is used to test the goodness of it. So R square is one of the measure used to test the goodness of the fit. So this is the formula for R square, which is 1 minus the summation of individual calculations minus the mean or the line divided by the y minus the total variability in the data. So the value of R square lies between 1 and 0. So 1 means it's a good fit and 0 is a bad fit. Then we also have the adjusted R square. So it's just takes into account the number of independent variables also. So we'll just see. So in a linear regression equation, what does the
That is be the answer.
slope coefficient? What is a slope coefficient?
तुम क्या जानो एक बूंद पानी की कीमत 10 लाख क्यों का वीडियो तो तब बैठे हो जरा एक अरे अरे वो कर दे ये तो
There is so much background. So can you please mute all?
Yeah, I'm trying to mute, but I cannot find it.
So for the first question, what is the answer? B.
Yeah, I will just come. I will try to mute.
Question B is the answer.
Yeah, 1 minute. So somebody from outside has started. That's the issue.
B is the answer.
So for the first question, the answer is the slope coefficient is a change in dependent variable for a unit change in independent variable. B is the answer. And for the second question, so what is the coefficient of determination R square? So it's the accuracy of the model, or sorry, the proportion of variance explained by the model. So let's see how we will use this is the formula. So here is an example. So here x is our independent variable and y is the dependent variable. So what we need to do is we have to find, or we have to find the line which best fit this data. So what the steps that we will follow is, so first we have to find the mean of x and mean of y. And then if you remember the formula, we have to calculate x minus, so again, go back to the formula. So here is the formula that we have. So we need to find the mean of x, mean of y. So that's definitely it. Then we have to find x minus the mean, then y minus the mean. All right, so let's see. So here we are finding the mean first. Then we will find the x minus the mean for each values. So we have those here, and also y minus the y mean. So we have that also here. Then we'll calculate the covariance between x and y and the variance of x. So the covariance is calculated by x minus x bar into y minus y bar. So yeah, here we will get the two terms xxx and sxx. Then we have to find the beta 1 and beta naught. So beta 1, the formula is sxy divided by sxx. So we get 1.743. And for beta naught, we have the formula y bar minus beta 1 into x bar. And we find the beta naught. So the final equation is y is equal to beta naught plus beta 1 x. Now to find the r square value, we can use the r square formula. So here we have the y minus y bar whole square. So this y bar is nothing but we will put each of the x in this equation and we'll find the y cap, whereas y bar is our mean y bar that we have found initially. So if you look at the final r square value, we'll get a very good fit, that is 9936. Even if we calculate the adjusted r square value, we will get a good number. So that shows that the line is giving proper fit to the data. So this one you can try. And yeah, so if you want to try now, you can try. Yeah, tell me.
Hello, excuse me.
Yeah, please.
Are you able to hear?
Yeah.
Yes, I was asking whether can we get the recording or not.
Yeah, I will upload the recording.
Okay, sir. Thank you.
So here also we'll have to follow the same steps. So if you do the same steps, you will get the answer. So I'll skip it. You can try it later. All right. So now we will see some of the sum square quantity definitions. So here we have the sum of squares of error. That is sum squared error, SSE. Then we have the sum squared residual. Then sum square total. So what does all these terms mean? So here we are calculating the error with respect to the line. So
Sir,
y bar.
not
But you are not audible, sir.
Sir.
Yeah. Am I audible now?
So you were always audible throughout.
All right. Okay. So error means like we are calculating the distance from the point to the line. Okay, then mean means so sum of residual will be the mean minus the line, and we have the total will be the individual point minus the mean of the data. So if you see like we can see from the graph that SST is the total. So the total will be the sum of the error plus the residual. All right, then also the R square that we have already calculated for the R square regression fit, that is nothing but 1 minus SSE minus divided by SST. So here we have some questions. So which of the following formulas correctly calculates SSE? You have to always remember SSE is the error. So error will be always calculated between the actual point and the regression line.
It's B.
Yeah, first question, the answer is B. And which equation relates SST, SSC, and SSR?
A.
A is correct. Yeah, A is correct. And one more answer should be correct.
So D.
Yeah, A and D both are correct. All right. Now, what is the possible range of values for R squared?
So B.
Yeah, B is correct. So if SSE is 200 and SST is 800, so what is the value of R squared? Remember the formula, the R square is nothing but 1 minus SSE divided by SST.
Yeah.
1 minus
C.
Yeah, I think C is the answer. 6.
A. Nine.
It's C is the answer.
B.
Dhana, mic yo.
Okay. So if the linear regression model perfectly fits the data, so what would be the value of the SSE?
Sir, A.
Yes. And for the second question, what happens to R square when the regression model's fit improves? R square decreases, increases, or remains unchanged? What is the answer? R square should improve, right? So now we'll see the classification problem. So classification is nothing but we are assigning or it's a supervised task like assigning different class to the data points. So some of the examples of classification problems are email spam detection or sentiment analysis, image classification, medical diagnosis, fraud detection, and language identification. So this is just a overview or what classification can do. So if a new file is uploaded or if we have an incoming attachment, we'll use a PDF classifier to classify it as whether it is an invoice or whether it is a CV or is it a proposal. And by automating some task, we can automatically send these documents to the concerned departments. Like if it is an invoice, we can upload to accounting team, or if it is a CV, we can notify the recruiting or the HR team, or if it is a proposal, we can forward to the procurement team. So we have two types of classification mainly. So one is the binary classification, in which only two classes need to be classified. Like if you show an image and if you ask the model to predict if it is a cat or dog, then it is a binary classification. Then we have multi-class classification, that it has more than two classes. So let's say we trained our model on the vehicles and asked it to classify whether it is a two-wheeler, three-wheeler, or a four-wheeler. So that comes a multi-class classification problem. Then we have linearly separable. So if the data is linearly separable, then we can call it as a linearly separable problem. So here we can just draw a line and separate the data. So if it's a non-linearly separable problem, so here either we'll have to draw 1, 2, 3, 4, 5, a lot of lines, or a non-linear boundary has to be used to classify the problem. Logistic regression. Even though the name is logistic regression, it's a classification technique. So classification, it's a classification in which we draw the linear boundary. So goal is that given new sample data predict the class from which the data point is likely to have originated. So let's see how we can do that. So to classify two classes, first we have to set a decision boundary, that is an equation or the linear equation. So the value of this equation may vary from -infinity to +infinity. So in regression, what we do is we set the value to some threshold. Sorry, in classification, we put some threshold value. Then if the value is above that threshold, we'll put it as one class. Then if the value is below that threshold, we'll put it into the other class. So let's see how we will do that. So we have a linear boundary equation. So that is beta naught plus beta 1 into x. Then we use the sigmoid function on that. So if we apply the sigmoid function is defined. So this is the sigmoid function we have. So if we apply the sigmoid function, that is 1 divided by 1 plus e raised to minus beta naught plus beta 1x. So either it will give the value between 1 or 0. Now here, if it set the threshold as 0.5, so whatever comes in this part, we'll take it as one class, and whatever it comes in this part, we'll take it as the other class. So here is an example of how the decision boundary is set. So the beginning, the decision boundary will move away, so that the error is high, and in the end, the decision boundary is correctly set so that both the classes are separated. So what type of machine learning problem is a logistic regression primarily used for?
B.
Yeah, B. So now you have just seen the problem, so you can easily answer. So always remember, even though there is a regression in logistic regression, it is always a classification. It is used for classification. So in logistic regression, what is the output range of the logistic function or the sigmoid function?
B.
Yeah. So what is the purpose of sigmoid function in logistic regression?
Why just
A.
Yes, it's correct. And in logistic regression, what is a cost function that is minimized during training? So I haven't discussed it. So if you know, you can just say that.
B.
Actually, it is cross entropy loss. Okay, so I haven't mentioned that. So cross entropy loss is a loss function that is used in classification problems. So in logistic regression, it's gradient descent. These R square, mean square error, mean absolute error, RMS, everything is proper regression metrics. So in classification, we usually use accuracy, precision, recall. So if you remember the confusion matrix that we have seen in the last class, so that is used in mostly in classification problems. If you remember one hot encoding, you can answer it.
B.
Yeah.
B, I think.
Yeah. So one hot encoding, we will convert the categorical data set into zeros and ones. So this is the performance metric that is used for so this is otherwise called as confusion matrix. So here we have the predicted class and actual class. So if you predict the correctly,
I have a doubt.
yeah, please.
In the exam, this type of questions would be coming, right?
What?
In the exam, this kind of exams would be coming, right?
Yeah, mostly MCQs will come, I think.
And the center we'll know in next week.
I don't know exactly that. You will have to mail the NPTEL team.
Okay. Yeah, you can continue.
So if we have predicted a positive or the true class as positive, then it is a true positive. Then if we predict that actual positive to be negative, then it's a false negative, which is also called as type 2 error. Then if we classify a negative as positive, then it is a false positive, which is a type 1 error. And negative to be classified as negative is true negative. Then we have some metrics. So if you remember this table, it's pretty good. So precision is nothing but nothing but true positive divided by true positive plus false positive. Precision is nothing but a measure of how much our model is able to truly predicted positive classes. Then we have sensitivity. So sensitivity is
Sir. Sir.
yeah. Have any doubt?
Sir, what if the prediction and reality match for a negative case?
Negative case.
Yes, for a prediction and reality matching for a negative case.
You want an example or what?
No, what is it called? It's true positive, true negative, false positive, or false negative?
Where? I didn't understand the question.
No, the question is that if the prediction and reality match for a negative case,
It's true
what
negative.
will be? It's true negative. Okay, thank you, sir. Thank you.
So it's like let's take an example of COVID. So if we test for COVID and it gives positive, it's true positive. If you have COVID, so if you don't have COVID and it gives a negative result, it's true negative. Like in medical terminology, it will be different, right? So some of the cases are true positive, precision. Then we have sensitivity. Sensitivity is nothing but true positive divided by the, or it can be called as how many how many actual true positives have our model predicted correctly as positive. So that is sensitivity. All right, then we have specificity, accuracy. Accuracy means among all the data, how many true we have predicted. So it's true positive plus true negative divided by the whole data, which is true positive, true negative, false positive, and false negative. All right, so try to remember this table. So it will be, it might be useful in the final exam.
Sir, thank you, sir.
Thank you, sir. Thank you so much.
Thank you for your class, sir.
The class is not over. You can, if you want to leave, you can leave. Otherwise, I will continue. So What is the purpose of confusion matrix in classification?
Sir, is it C?
B and C?
Yeah. Not B, it's not for regression model, it's for only classification. But so B is to measure the accuracy of a regression model. Its confusion matrix is used for only classification model. So precision is nothing but to identify true positives to all positive predictions. All right. So in binary classification problem, if a model makes 80 true positive predictions, 10 false positive predictions, 5 false negative predictions, and 105 true negative predictions, what is the accuracy of the model? Oh, our table. So we have 80 here. Then true negatives is 105.
92.5.
Answer?
0.92.
What will be in the top right? Is it 5 or 10?
10.
Here.
The 5.
Which one? 5 or 10?
185
Top
by 200.
This is 5, right? And here we have 10. So we have been asked the accuracy. Accuracy is nothing but 80 plus 105 divided by the total. So it will be 185 by 200. So the next one, the classification model predicts 180 instances as positive, out of which 100 are actually positive. So what's the precision of the model? So if you remember the precision formula, you can answer.
C 0.83.
Yeah. So here, what it actually is like, the total itself is given. So it's easy to. So the total is 120. So 120 is total predicted positive cases, out of which the true positives is 100. True positives is 100. And 20 is false positive. Okay, so now we have the ROC curve. So ROC curve is called as the receiver operating characteristic curve. So it's a graphical representation of a model's ability to distinguish between two classes. So the if we plot the ROC curve for a model, so it always has to go. So if you, so this line that represents the 0.5%. So if in a binary problem, the probability of one data point to be in any of the class is 0.5. So if our model is predicting, or if the ROC curve falls in this range below the line, then we can say that our model is performing bad than a human, or we cannot use that model anywhere, because a 0.5 is the minimum accuracy which a model or expects for a binary classification problem. So in a perfect classifier, we know that the true positivity rate has to be 1, but it is hard to achieve that. So how far this line goes, the model is better.
Sir, I have a question from the previous graph.
Yeah.
Sir, what is mean by false positive rate or true positive rate? Is it like during the fitting?
No, true positive and false positive rates are nothing but precision and precision and sensitivity. 1 minus sensitivity.
So in a single set of data, these
Yeah.
are basically a point, right? It's not a line. It's a point. It's a single point. So how can I get this information?
I didn't get you.
So suppose I have my own model and I'm trying to feed my data. So I should get from the data set a single number, right?
Yes.
So in this graph, like if I try to plot in this graph, you have 3 different lines, like dotted line and 3 solid lines. But
the 3 solid lines are for so let's say so these 3 are different cases.
So in actual, like in my data set, I will get only a single point, not the whole line, right?
Okay, you will get only 1 point.
Yes. So
So,
how
but
do I know? How can I judge?
so it's like how to you're asking how to plot this or what?
Yeah, like if I want to see that on which direction I am actually going, how do I know whether I am going to better place or as you told that my model is I cannot use my model if it is worst case. So is it like in this 0 to 1 and 0 to 1 in this area, I will see where my data points is coming, and if it is improving, it should go to the top left corner, right? Is it correct?
Can you repeat?
So suppose in my data set and my model, I will get a single point, and when I do plotting in this 0 to 1 range of this false positive and true positive case, that then my point, if my point is moving towards the upper left corner, that means my I can use my model or my model is validated. Is it correct?
Yes.
Okay.
So it's like so let's say we have sample AB. Let's say we have sample A, B, C, D, E, F. Then if we predict if we give our sample to each model, then we'll get different probabilities, right? So we can get different probabilities like ranging from 0 to 1.
Yes.
Yeah. So if we have set, so in the output we will restrict our probability to be 0 to 1. So what we can say that so let's see. So let's say we have class A. So sample A is class 1, and our model predicted the score of 0.9. So its actual class is correctly predicted. Now for the second case, so let's say we have our another class sample B, whose actual class is 0 and the predicted probability is 0.3. So that is below 0.5. So below the threshold, so it's class 0 class. So we can say that from this, what we can do is we'll first put the threshold. So for each probability, we can set as a threshold.
Okay, thank you. I got you.
Right. So if a classifier has true positivity rate of 0.9 and false positivity rate of 0.15, so what is the specificity of the classifier?
Point 0.9, is it D?
I will see. For the next one, question number B. A classification model has 120 true negatives and 30 false positives. So what's the false positivity rate?
Is it 30 by 120?
Not 30 by 120. So 120 true negatives and 30 false positives. So what's the false positivity rate?
Sir, A.
Yeah, A is the correct answer. So we look at the formulas. So specificity is 1 minus false positivity rate. So the answer is C. Yeah. So this is false positive divided by false positive plus true negative. That is 0.2. So that's about classification. So now we'll quickly see what is KNN, K nearest neighbors. So it's also a classification algorithm that is different from the what we have seen right now. So let's see. So let's say we have some images of dogs and horses with heights and weights. So this is our data. So we know that the horse is both higher than dogs and it weighs more than dogs. So we can see a specific pattern in the data. And the KNN, what it does is, it will classify the data without any label. So that like by calculating the features or by taking the feature of each of the data, that will classify how the data are close to each other. So the main aim is, so if you put a point here, so that it will check what the neighboring points are, and it will classify the new point as a horse or a dog. So in this case, this point will be corresponding to horse, and this will be dog, and this one will have to see how many nearest points are horse class, or which class is more closer to the new point. So in training algorithm for the KNN, we'll store all the data. Then prediction, we'll calculate the distance from the new point to all points in our data, and sort the points in our data by increasing the distance from X. And we'll see, or we'll set the K value, like we can set the K value as is a user defined value. So if it is 5, it will see the 5 closest points and take the average and send the new point to that class. So here is an example. So choosing a K will affect what class a new pointer is assigned. So let's see using this example. So we have class A, which is yellow points, and class B, purple points. So star is our new point. If we have set K is equal to 3, and so these are the 3 closest points to the star, and the higher number of points in that 3 is B. So this star will be assigned as class B if we set K is equal to 3. Now, if we increase the K is equal to 6, then the class A has 4 points inside this big circle, and class B is having only 2. So the star will be classified as class A. So the choice of K will affect our classification. So here, if you see how the K is going to affect. So K equal to 1. So if you train our model with K is equal to 1, so we can see that here the range in the intersection changes. So some of the points are classified as dogs, and some of them are. So this is actual host, this red. Whereas if you look at here, it will be classified as dog. Now, if we increase the K, we can see how the decision boundary changes. So what are some of the advantages of using K and N?
Sir,
So
sorry.
Yeah.
Sir, how do we choose the best value of K? Like choosing K is affecting which class my new data point will be belonging to. So like
Yeah.
how do we reach to the best value like of K? What should be the correct value or the closest one for the right classification?
That we cannot say, right? Like for each model, it will differ. So one way to do is, so during validation, we can set this K. So during the testing phase, we will know if like we can train for different K values, and during testing, we will put the unseen data to the model, and we can find the error in that case.
Okay. Thank you, sir.
So some of the advantages of using KNN is it's a simple model, and always the training always converges, and it also works with any number of classes. And if we add more points, so if we add some more points here, it's not going to affect the overall working of the model. Then it has very few parameters, like it's only the number of K we have to see and what distance metrics that we are using. But the problems are, it is having high prediction cost. So what high prediction cost means is, so if the data set is large, so we have to calculate the distance from one point to all the data sets, and we have to calculate, sort it, and calculate the nearest points. So it can be computationally expensive, like in the storage and all, if the data set is large. Then if the data set is high dimensional, so all these examples we have seen only 2 height, weight. So only 2 features are there. So if there are more features, like the finding the distance itself will be a challenge. Then always numerical data sets only works with this. So if you have categorical features, like it's difficult to find a proper metric which finds the distance. So just some questions.
So sir, for the
which of the
categorical features, we can't use any encoding scheme here and then do it?
no, it's so even if you, so let's say we have categorical data. So let's say we have some categorical data, then we use encoding. What encoding we'll use? 1010, or so
One
let's
hot
say
encoding.
one hot encoding. So it's all 1 0. So all the points will be at either. So this, if this is 0, this is 0, all the points will be here, then all other points will be here. So there is no meaning. So no meaning in the sense like, so let's not talk about one hot encoding. So let's say we choose the numbers 1 to 12 for our months from January to December. So by what sense we will find the distance? So if you see, December is close to January. So December is close to January in some sense. But if it is 1 and 12, then if you find the distance function, it is far in one sense. Yeah, so that can cause problems. Like the numerical values that we give to these categorical data will not make sense.
Okay, sir. Thank you.
So which of the following statements is false about k nearest neighbor algorithm?
B.
First question.
Yeah, sir, is it B?
It's actually not B.
It cannot be used for regression.
Yeah, C.
Yeah, C
Yeah.
is the answer.
C is the answer. And for the second question, which of the following statements is not true about KN and classification?
D.
Yeah, D is the correct answer. So here is the explanation. So basically KNN can be used for both classification and regression. So in case of classification, we will choose the nearest neighbor. In case of regression, we will calculate the average value. Yeah. What is the, so we have data from a survey and objective testing with two attributes A and B to classify whether a special paper tissue is good or not. Here are 4 training samples given in the table. So now the factory produces a new paper tissue that passed laboratory test with A is equal to 3 and B is equal to 7. So if K is equal to 3, then good is the classification of this, then good is the classification of this new tissue. So is it true or false? This is the model that we have. Our new paper has A is equal to 3, then B is equal to 7.
Is it false?
Use K is equal to 3.
So how do we approach this problem? Like,
Yeah, we'll see that. So
I just made a guess. I told false.
okay, fine. So we'll see how we will approach this. So this is how we will do it. So this is our table. So what we have to do is we have to find the distance function, right? So we actually have is, so let's try to draw it. And now we have the point A767. So this is 2, this is 4, this is 7. Then we have B6, 4, 6 and 4, 6 and 4. So we have how many bad points? 7, 6 is bad, so this is a bad point. Then 7, 4 is also bad, so this is also a bad point. We have 2 good points, 2, 4, so this is good. And this is good. Then we have A is equal to 3, B is equal to 7, so we have 1 point here. So this is our point which we need to determine. So what we need to do is first find the distance from each of these points. So we have B. So all this distance we have to find. So here we are finding the distance, a square distance to the query instance, that is 7 minus 3 whole square plus 6 minus 7 whole square. So we have the distances. So first we find the distance. Then we move to find ranking them. Right. So 1, 2, 3, 4 based on the distance. Then we set the k value. So k is 3. So we'll select which all points we need to choose. So we have 2 yes, 3 yeses and 1 no. So we'll not consider this point and we'll select the other 3 points. Sudarshan, you have a question?
Yes, there are 2 10, but we make it 1 and 2. On which basis I made?
This one too.
Yes, yes.
It's both the same. It's equidistant, so it's okay.
Oh, okay.
So in case if you have like in case if you have only one, so let's say the distance is same, then we have one good and one bad, and if our k is equal to 1, then it makes a tough choice whether to choose this one or choose bad or good. Usually that's why we don't we will use higher number k. K is equal to 1 will give very bad results usually. So at least k is equal to 3 or 5 we use most of the cases. So here we have two goods and 1 bad. So whatever we have predicted is true. The majority goes with good. So now we'll see briefly k-means clustering. So k-means
So
clustering
what
is
was the answer of the previous MCQ then? Like the answer is true or false? Okay.
It's true. It's true. It's true.
Okay. Thank
The
you.
majority is good, right? So good, and 1 bad.
Yeah, thank you.
So k-means clustering is an unsupervised algorithm. So that will attempt to group similar clusters together in our data. So we'll just use our model. We'll put some data into the model and it will automatically cluster similar documents. So here we have so this is our raw data, the black dots. Then we'll put this data into our model. And we say there are like 1, 2, 3, 4, 5 classes in this model. So the k-means clustering algorithm will group similar points together. So this is the final predicted output. So in this also we have to choose the number of clusters that we want. Then first we randomly assign each point to a cluster. Then I will use our metric, that is distance function, to classify each cluster. Then we'll follow the steps until the cluster stops changing or the points are fixed in a one cluster. So how do we do that? So this is our data. Then step 1, we'll assign each of the point to some random cluster. Then what we do is, so first we will find the centroid of all the yellow points. So that is here. then pink points and green points. So we here have 3 centroids. Then we'll find the distance between that centroid and other points. And if that is lesser, we'll reassign the data into new clusters. Finally, by iteration, we will be able to segregate the clusters. So choosing the k value also matters in this case. So if you choose k is equal to 2, we'll be getting 2 clusters. 3, and increasing the number, we will get different number of clusters. So again, in the last k and then nearest neighbor, in k means also like there is no, so here if you see like if we increase the number of k, we'll get clusters, that's fine. But what is the optimum value of k that we have to choose? So one way to choose that optimum value is an elbow method. So what is an elbow method? So first we'll compute the SSC for some values of k. So like for different clusters, we'll calculate. The SSC is defined as sum of square distance between each member of the cluster and its centroid. All right. So once we if we plot the k against the SSC, we'll see that the error decreases as k gets larger. So this is because the number of clusters increases, the centroid will become closer to the points. So the distortion is smaller. So the simplest example is like, so let's say if you have 4 points, and if we start with 2 clusters, then we'll have at least 2 groups. And if you move to 3, then we'll have 1 and 2 points. And if you move to 4 clusters, so let's draw it. So if you have, so let's say we have 4 points, 1, 2, 3, 4. So if you have only 2 centroids, then we'll classify this as, so there is still distance between this point and this point, and we have distance between this point and this point. Now, if we increase that to 3, so we can actually keep, can I change the color? So I can actually keep our point to be on the centroid. So if we keep the point on the centroid, the distance or the SSC is 0 for these 2, and we will have another one more centroid, we'll have this much distance error. Now, if we increase one more point, if we use 4 points and 4 centroids, we can actually keep our centroids on the points and the SSC will be 0. So increasing the number of k will reduce the SSC drastically. But our in most of the cases, the points are not 2 or 3 or 4. They will have a lot of number of points. But still, if we increase the number of centroids, the SSC will reduce. So what is elbow effect? So here we have 4,000 samples in total. So if you have only one centroid, so let's say each centroid has 4,000 points. Sorry, this is not centroids, the sum of squares. Okay, it's not the points, it's sum of squares. So if you have only one centroid, the sum of squares will be higher. Then if we increase the number of centroids, the SSC will come down. And at one point, if you see, this actually looks like our elbow, our hand. So that is why it is called elbow effect or elbow method. So whenever the graph shows a flat curve like this, we can say that the number of centroid, that is 6, is the optimum number of centroid in this case. So this is the elbow method. So how can we say if a clustering is good or bad? So we have the intra class, that is intra-cluster similarity is higher and inter-class similarity is low. So inter-class means within the class, it has to have high similarity, and between the class, the similarity has to be low. So we have another metric to calculate that is called the silhouette score. So in unsupervised machine learning, determine the right number of clusters is crucial. So two widely used techniques are elbow method, which we have already seen, and the silhouette score. So elbow method we have seen. So this is how we calculate inertia in the elbow method, where mu is the centroid of the cluster, and this is the squared Euclidean distance. So we have to sum the each cluster points with the centroid of that cluster, add those, and we have to add all the clusters. Now, what is silhouette score? So silhouette score measures how similar a data point is to its own cluster versus other cluster. So its values ranges from -1 to 1. Higher means it's a better clustering. So let's see the formula. So formula for the silhouette score is B minus A divided by maximum of A comma B. So what is A and B? A is the average distance from X to all other points in the same cluster. And B is the lowest average distance of X to a point in another cluster. So A is the distance of a point. A is the distance of a point to all other points in the same cluster. So let's try to draw it. So have another cluster. All right. So let's say this is 1 point. So this is actually correctly classified. So if we calculate the distance between all the points of this cluster, red cluster, we'll have B, A. Then B is the lowest average distance of X2 points in another cluster. So in this case, the average distance to green will be less. So B minus A, maximum of A by A, maximum of A or B. So the maximum will be B in this case, because B is the distance of, so let's try to draw. Let's say B is this distance averaged, then A is this distance averaged. So we know A is less than B in this case. So B minus A will be positive and maximum will be B. So it's a positive number divided by the B. So it will be somewhere greater than 0, close to 1 or not. So it's a good fit. Now let's say we have another point here. So this is classified as red point again. Now we are calculating the distance. So the A is this distance, which is high. Then what is B? In this case, the B will be this distance, because B is the distance of that point to another cluster. Lowest average distance of X to another cluster. So in this case, B is smaller and A is bigger. So B is smaller and A is bigger. So in the numerator, we will have a negative number. And the maximum is A or B. Maximum will be A. So we'll have a negative number as a S as the Silot score. So which makes it a bad classification. So when to use elbow method? When we need a quick estimation of K. So it works well with low dimensional problems and well separated clusters. And also it's efficient for large data sets. And when we have to use this Silot score, it's useful when clusters overlap or boundaries are, so we have very complex geometries or complex decision boundaries, then we can use a Silot score. And it's more objective criterion. So we'll have to satisfy the interclass and intra-class separations here. That is very well captured in Silot score. Then it handles small as well as complex data sets, but it's slower because it has to calculate the distance between the same class, then different clusters, and we have to see which is lowest, and all those things will come. So the best practice in k-means clustering is to use elbow method to narrow down the final candidate of K. Then we use the Silot score. So it combining both these methods will ensure efficiency as well as accuracy of the model. So final set of questions for you. A second last set of questions. So which of the following is the goal of clustering algorithm?
So D.
Yeah, D is the correct answer. So in k-means clustering, which of the following techniques can be used to address the sensitivity to initial placement of cluster centroids? We had
Sir, D.
yeah, D is the correct answer. Both B and C can be used. Then in k-means clustering, what is the purpose of the Silot score?
C, sir. Evaluate quality of the.
Yes, C is the correct answer. And which of the following is a limitation of k-means clustering in handling imbalanced data sets?
Sensitive to outliers, P.
Not actually outliers. The actual answer is A. Like the problem is the k-means clustering usually we do the averaging, right? So even if we have 1 point or 2 points, the averaging will assume, or the clustering will assume, that all the clusters are having a similar number of sizes. So even if there is an outlier, it will only move to one of the cluster, the outlier. Even though the centroid will move more towards outlier, but still it is classified. So it's not. So correct answer is A. So that's it for today. So if you have any doubt.
So this content is actually too much for a single day. I know you have time constraints, so you have to cover. But it looks like very heavy for just 1 day, 1 hour. I mean, back to back. So many algorithms.
Yeah. But still, it's okay. Means you already have studied, right? So it's kind of like refreshing, maybe. Like if you have watched the lectures, previous lectures, then it's kind of easy.
Actually, I too felt the same. Week 4, all the videos, I felt it was overloaded.
Like the thing is, actually this is 4 week so this is an extra section that I have to ask for the NPTEL team. So and they only give one extra section of 2 hours, so I had to compress everything together.
So isn't this content actually heavy for 4 weeks? I mean, like whatever we have covered. I was wondering, it is around 3-4 months ka content which we are doing. I know it is a time factor, like it's no one's fault, but it is actually too much to go through. I mean, time is a factor, like at all ends, but like it's no one's fault. But then it actually needs time to absorb everything.
Yeah, actually,
because it has so many formulas, maths, everything involved.
Actually, this 3 is like I had given another course, data science for engineers. So these 3 are 3 different 2-hour sections. So total 6 hours I had to spend for these 3, including the tutorials. Yeah. Including
it is
the
a lot of work at your end also, making these PPTs. Like it takes a lot of time and effort also.
Yeah, it's fine.
Sir, when you will share this with us, you will share these MCQs and the embedded answers will be embedded within these slides?
Yeah, everything will be there. So I will upload this in the same drive link. I hope you have access to that.
Yes, sir, we have. Thank you so much.
All right, then see you and all the best for your exams.
Thank you, sir.
Thank you, sir. Thank you so much.
Thank you. Thank you,
right.
sir.
Thank you, sir.
Yeah.
So, sir, this becomes our last class, right?
Yeah, this is the last class.
Okay, sir. Thank you so much.
All right.
Thank you, sir.
Hello, sir. Thank you so much for this nice session. Actually, where is the drive link? I don't have that link. Just only I have the link, all the videos in the Swayam portal, not other than this. Could you get my point, sir?
The drive link.
Hello?
Or, can you hear me?
Yeah, I'm hearing you, sir. Please carry on.
Yeah, the NPTEL team might have shared the drive link. One document, Excel document.
No, I don't have any because I have only the recorded videos before.
There is a like when you open to log in the portal, you will see on the left there is something called a problem solving recording.
Okay,
so if you click there, if you click there, it gives you one line of text and which says that click here to view the problem solving session lectures. So you click on that hyperlink, click here, and it takes you to a Google Sheet. Right? It takes you to a Google Sheet which has all the links.
Okay, so all things are there available.
Yeah. It has all the links.
Okay, thank you so much. Thank you.
Thank you.
Thank you, sir.
I will upload the files in the drive and video in the YouTube. All right. Yeah, thank you.
Okay, sir. Thank
you.
Yes, sir. Yes, sir.
Right.
Thank you, sir.
Yeah.